Okay, so continuing off what we did in the last video, we finished our easy circuit. So now in this video we'll be going on to the core chart. So for those who have done this before, you just click center core chart at the top of your screen, the top bar here, this icon that says center core chart. Now click it once and it'll open it. Wait for it to start up like that, and then you can maximize the view. So now with this, you want to test it. Basically, you want to grab the robot car, plug the cable in, the data cable. So first you want to plug the data cable into your laptop, and then plug the cable into your robot car. And when you're plugging in the cable into the robot car, make sure that you press down the button on the STEMSEL board. And also, when you plug in the cable, make sure it's the right end of the cable. The flatter end of the cable goes into your laptop, and the squarer end of your cable goes into the STEMSEL board. So now you want to do this test, send program to chip. Make sure you hold down the button, and you also have to give it a name. So find where you put it, line following, and then enter the name. Oh. Okay. Now it's going to send it, and it should say programming was successful. Then you click OK, and there you go. So in order to test it, you have to unplug the data cable and either use the battery on your robot car or plug in the data cable without pressing the button. So if you want to use it without the data cable, make sure you put in the battery connector into the STEMSEL board, flick the on switch on the STEMSEL board, and then flick the main switch on the robot car, and then it should start testing if your motors are connected in properly. And if they are, so this is how to tell if it's correct. It should turn your left motor, if that was your motor 1, forward, backwards, and then your right motor forwards, backwards. And then after that, you want to delete the test, because if it works, we don't need it anymore. Just click yes for both of that. So first of all, we're going to need to use the LDRs that we put onto our STEMSEL board. So you want to go to input, because light sensing is an input going from the light sensor into the STEMSEL board, and it's an analog input because it's kind of like an analog clock. It ranges from 0 to 255 instead of 0 and 1. So if you click the analog in, you want to add 2 of them. Now in order to add them in, you make sure you press the arrows. Then you want to double click on the first analog, get the right sensor, save it as right volts. Then you want to click the second analog in, and then do the left sensor. Make sure you click the left sensor in the drop down menu instead of typing it in, or it will think that it's a different thing. Then you want to save it as left volt. Enter. So right now it should look like this. And the reason we're doing the analog input is so we can collect data from the light sensor. If we don't put in the analog in, then the microchip is going to be like, I don't know what to do with these LDRs. It's going to pretend that they don't exist. So you want to tell the microchip that they're there, so you want to make this analog in. Next, what we're going to do is we're going to go to numbers, because in order for the robot car to work, here's the theory behind it. We get the right sensor, and then we get the left sensor. We convert their readings into the left volt, right volt. Then we want to compare the right volt, and then with the left volt, and do anything that's above or below. And the reason we're doing that is because, as I said earlier, if the car drives slightly off the line, one of the sensors will detect that it's not on the line anymore, and try to correct it by driving the wheel on the side of the light sensor. So, if the right volt is below the left volt, that means the right sensor, the right side of the robot is off the line. So if the if the car is on the right side of the line, you want to turn the right motor on in order for it to turn back onto the line. How we're going to do that is, since motors are an output, because the chip sends a signal to the motor, not the other way around. So we go output, go on off pin, and you want to add 2 of them by clicking the arrow twice in below. And then you want to turn on the right forward and turn off the left forward, like that. Then you want to group them together, call it right forward. Create new group. Right. Let's call it right side then, like that. So which means it's going to compare the right sensor, change that right sensor reading into right volt, get the left sensor, changes that into left volt. It's going to compare the 2 light sensors here, decide whether the right is above or below, and then turn on which motor. Then we go back to output, 2 on-off pins after the above. Same procedure except left forward is on, and then right forward is off. Then you want to group them together, call it left side, like that. So now we got that, we are missing 2 things. The number, the time delay, so we go into numbers and then scroll all the way down to time delay, because alphabetical order. And then we double click the time delay, set it for 3 10,000s. The reason we wanted to set it for 3 10,000s excuse me and not 3 seconds is because what's going to happen is it's going to turn on one of the motors on the side, then it's going to wait 3 10,000s, that's 0.0003 of a second before it goes back and checks it. But it can't go back if we don't put a go to. So we need to go to start. That way it does the 3 10,000ths time delay and then goes to start without ending. Because if it ends, it's not going to keep reading or keep comparing. It's just going to stop. So now with that covered, the reason we're going to do this is because before it goes to start, we want the wheels to spin a bit. Because if we don't let them spin, they're just gonna move quite slowly, because you don't let it turn on for enough time for it to actually drive. Now, with that coding done, that's actually the end. That's all you need for a line following robot car. And when you think about it, it's quite simple and, you know, basically what you would expect. So now this video is going to come to a closure, but there's going to be one more video on the testing, because I'm not going to put it in this video, but what I'm going to do in the next video is I'm going to get the robot car and put it on one of the tracks. But before we do that video, I just want to clear up one more thing with the coding. When you finish coding this right here, make sure it's correct. I'll just show you inside, right forward, left forward off, left side, left forward, right forward off. And if you missed any of it, you can pause and go back in the video. So now, we get our cable again, hold down the button on our STEMSEL board, and plug in the cable. Then send the program to chip. It's going to do all of this. Wait for it. And then it should say programming was successful. So now you click OK, unplug it, and then your whoops, I just hit my microphone. And then your robot car should be ready to drive. Now you just want to flick the main power switch on the board, and then it should start going. But it's not really going to follow a line if it has no track. So I'll get into that bit in the next video. For now, hope to see you again next time.